Alright, so for this problem, we're asked to develop a regression model to predict the appraised value. And we're going to use the variables, the acres of land, the square feet of the house, how old it is, how many bathrooms, how many rooms total, and the garage. Let's just do a quick check. Let's do a correlation just to show you how to do that first. And we're going to go to data analysis, and we'll run correlation. And the input range is going to be all the variables for the entire range all the way down to the very bottom. And I did identify the labels in the first row. That's a good practice. And let's make the output range J1. And the reason I like to do this first is because I can get a sense, so there's the appraised value, I can get a sense of what's highly correlated with appraised value. So for example, house size is highly correlated, which means it's probably going to be a good predictor. You'll notice that age is negatively correlated, meaning as the house gets older, it becomes less in appraised value. And you can see the correlations here. Now, some of the other interesting things, of course, if you were to look at, say, the number of rooms with the size of the house, you'll notice it's about a 0.50 there. And number of bathrooms tends to go up as the house size goes up. So a lot of this makes intuitive sense, but that's just valuable to look at. But now let's go ahead and run some regressions on the data and see what we get. So I'll come in here to data analysis. Now we're going to run a regression. My Y range is going to be the appraised value, which is in B1 to B91. My X range is going to be everything all the way across the appraised value, not including the appraised value, so just the 6 variables that I'm interested in. You can see I've highlighted that whole range. I did identify the labels in the first row, as you can see up here, so let's check the labels box. And then we'll put the output in J11. And let's take a look at what we've got here. So we've got 71% of the variation explained. There's the equation. And now this equation basically says you take 64 plus 402 times the number of acres plus 0.14 times the house size minus 0.68 times the age plus 54.8 times the number of baths minus 14.3 times the number of rooms plus 10.2 times if it has a garage or not. And in fact, this is how many garages, 0, 1, or 2. Alright, so one of the things you'll notice is, first of all, is that we have a significant model. Remember that e to the negative 21 means that you've got 20 zeros and then 826. But if you look closely at the p-values associated with each of the intercepts, you'll notice that, for example, land, house size, baths, these are the only 3 that are significant given the other variables in the model. And it's very important to remember that when you have many variables in the model, and remember, based on our correlation up here, some of these are correlated to each other. So when you have many variables in the model, they're actually explaining a lot of the same variation. As we pointed out, as your house size goes up, so does your rooms and baths. So what we want to do is take a look at these p-values and decide which one is contributing. P-value associated with garage is 0.66. You'll also notice that the that's a pretty big p-value, right? Because we'd like it to be below 0.05, and it's the biggest of the batch. You'll also notice that the t-statistic for garage, right, if you compare it to the others, it's the smallest. In other words, it's not very different from zero, and in fact, statistically, based on this p-value, we can't conclude that it's different from zero. All right, so what we want to do is we want to take garage out of consideration. Well, we're lucky because it's already over here on the far end, so we don't have to move anything around. But what we do have to do is go back into data analysis. We're going to run a regression again. But this time what I want to do is I want to change my variables so that I do not include the garage. And so what you can see here, I've highlighted all the data, but I've only highlighted 5 columns. I have not highlighted the garage data. I need to change my output range because I don't want to overwrite, so I'm going to drop down below the last one there and click OK. All right, you need to notice a few things first of all. So let's first take a look and notice that we have one less variable because we no longer have garage here. But the other thing I want you to look at is notice that the coefficients have changed. Okay, so if you look at the coefficient, if you look at the intercept, it went from 64 to 71. Land changed from 402 to 409. The coefficient on house size changed from 0.142 or 1395 to 142. So what this is showing you is that the other variables had an impact on the variables that were already in the model. So we can then take a look though, and you'll notice that by removing garage, we didn't change the R-squared very much. Before we were explaining 71.72%, now we're at 71.66%. So we're actually not explaining very much less variation, and the reason is because garage wasn't contributing to the solution anyways, because in the last regression it was not different from zero. This 10 was statistically not different from zero because of the variation in the data. All right, so let's take a look. We do still have a significance model and a significant model, and what that tells you that at least one of these coefficients is different from zero. And if we look at the p-values associated with the coefficient, again, we can see that age is not significant. The rest of these are all less than 5% except for rooms, but age is kind of the worst offender, I would say. So let's take age out of the equation now. Now this time, the trouble with age is it's right in the middle of our data. And when we try to highlight our X's, we have to highlight one contiguous range. So I'm going to highlight that column, I'm going to cut it, and I'm going to bring it out here and insert it at the end. I don't need garage anyway, so. All right, now I can come in and let's run data analysis again. Run the regression. And I'm going to highlight land, house, side, bath, and rooms. And again, I'm highlighting all the data all the way down. I have to change my output range so I don't overwrite my last output. Click OK. And once again, let's look at a few things. So now I've got a model with 4 variables. And you'll notice once again that the coefficients have changed. It used to be 409, now it's 418. You'll notice this time it went down a little bit on house size. That doesn't, it's not really, we don't care that much about whether it goes up or down. Just notice that it does change. So those are important. The R-squared only declined by a little bit. We're still explaining over 70% of the variation, even though we've removed two variables. Our model continues to be significant based on the ANOVA test. And finally, let's take a look at the p-values. So the p-value for land says that that coefficient is significantly different from 0, right? Same thing for house size, same thing for baths, and at a 5% level, the same thing for rooms. So that's our model, and basically we could set up our model to we'll write the formula down up above. I'm just going to copy this so that I can write it down in the box a little easier, and I'm going to paste it over here. So it says provide the alright, so it's 24.9 is the intercept, right? I'm going to delete some of these, let me size that up so we can see it. Alright. So I've got y equals 24.28, and then it's going to be plus the land in acres times 418. I normally like to put the number first, so let's put the number before we put the variable. And again, I don't need that many decimal points, so let's delete a few of them. And I'll just call this acres. Okay, and then it's plus, and this is going to be 0.14 times the size of the house. And then it's going to be plus 68 times the number of baths, and then minus 18.2 times the number of rooms. Okay, so let's go ahead and size that up. So there's our equation, and of course our R squared was 70.9%, and what that tells you is that this model with these 4 variables explains 70.9% of the variation in appraised value. And that's the answer to that question.